Hello guys, today we will be using RSA encryption to protect our tunnel. RSA algorithm is one of the most common algorithms for asymmetric encryption. Now just to quickly review the requirements for the asymmetric encryption, each machine has its own key pair, and when I say key pair I mean public key as well as private key. And the key distribution is going to be as following. The target will hold its own private key, and it will also hold the attacker's public key. And also on the Kali side, the attacker is gonna hold its own private key as well as the target public key. So when we want to send a message from the attacker to the target, we can use the target public key to encrypt that message, and the target is gonna use its private key to decrypt that message. And it's the other way around. When the target wants to send a message to attacker machine, it's going to use the attacker public key to encrypt that message, and the attacker machine is going to use its private key to decrypt that message. So right now the first step is to generate those RSA keys, and then we will update our code with those keys. Let's get started. So we start with importing the RSA class, and then we create a new object to generate a key with a size of 4096 bits. Remember that the higher key size, the more secure, but the slower operation is gonna happening. Now next we export the private and the public key in PIM format, and the .pim format is the most common format for the RSA keys, and it also can be used for network devices like firewalls, routers, as well as web servers. After that, we will export them into external file named public.pim as well as private.pim, and finally we will print out the generated keys. So let me go ahead and start running this script on both sides. Okay, so I will go ahead and type run as well as on the Kali side. Now please keep in mind that this might take few seconds to generate the keys. Okay, if we go to the desktop, we should be able to see both the public as well as the private keys. This is the public and this is our private. Let me just go ahead and open the public key. Okay, it's there, as well as the private. This is the private, and usually the Windows machine takes much more time than the Linux machine. Okay, so here is in the Windows machine, we also got the keys. Let me just go to the desktop to verify that we got the files. So this is the public, okay, and this is the private. Okay, perfect. Okay, so as we did with the AES before integrating the RSA encryption to our tunnel, let's first see how things will work. We import the PKCS1 class, which is an RFC standard for implementing an RSA encryption. Now this class as well will take care of the padding. Then we will define an encryption function where we will pass the message that we want to encrypt. Now inside this function we import the public key that will do the actual encryption for us. Then we create an encryptor object and pass the public key that will do the actual encryption. Now finally we pass the clear text message that we want to encrypt, and out of the function we will return the encrypted data. Now in the decryption function we will do something in reverse. We will import the private key that will do the actual decryption and then pass it to a decryptor object. So we pass the private key, and then we will call the actual decrypt function, and we will pass the cipher or the encrypted message that we got from the encrypt function. Final thing, we will just print out the message in a clear text. So let me just remove this and try to run this script. Okay, so let me run the script really quick, and if everything was working fine, we should get, this is the encrypted message and this is the decrypted message, and my message was just a letter H, so it's working perfectly. Okay, so before moving to integrating this script with our previous TCP reverse shell tunnel, I want to discuss that RSA itself is not designed to encrypt large messages. It has a limitation on the size of the clear text message. So when we are using a key size of 4096-bit, the maximum size of the message of the clear text message that we can encrypt, it is 470 bytes. Okay, so in this example, we just encrypted the letter H, which is 1 byte size of data. So that is less than 470, which is no problem. But if we multiply or increase the size of the message to exceed the 470 byte, then the RSA will fail to encrypt that message because it's too large to be handled. Let me show you the idea really quick. So let me just clear the screen. And instead of encrypting 1 byte, which is letter H, let me multiply this with, for example, 500. So we're going to encrypt a message size that is 500 bytes. Let me run the script. And as you can see, the RSA is complaining that the plain text is too long. So as I said, the maximum that we can encrypt, it should be 470 bytes. So let me just test again. That one should work. Okay. Now the idea, in order to overcome this, we need to check the size of the message. Here is the update of the code. As I said, before we pass the message to our encryption function, we're going to check the length of the message. So if the length of the message was less than 470, then it's not a problem. We can encrypt that immediately. However, if it was bigger than 470, then we need to split the clear text into blocks, where the maximum size of each block is 470. Now this for loop will treat the string as a Python dictionary, and we will start from 0 until the end of that message. However, we will take 470 bytes each time we iterate. Okay, so let's say, for example, that we want to encrypt a message size of 500. So let's say this is the message and it is 500 bytes long. So the first time we iterate, we will take the first 470 bytes. So this is the first 470 bytes. And this line here will slice the string, and we will take the first 470 bytes, and then we will encrypt them. On the next iteration, we will take the rest, which is 30 bytes, and we will encrypt them as well. Now notice that I made a little change on the encrypt and decrypt function. Now once we encrypt the block of that data, I called the decrypt function immediately, because my point here is just to make the code as simple as possible and show you the idea of the RSA limitation. So let me just clear the screen and try to run this script, and keep in mind right now the size of the data, it is 500 bytes. So let me do run. And as you can see, the first one, it is the first block of our data, which is the 470 byte of letter H here. And the second part, which is after the second iteration, which is the 30 byte that are left. So as we explained, the message size totally it is 500. The first iteration, it is 470 bytes of the total messages. And in the second iteration, we will encrypt the 30 bytes which are left. Okay, so let's see how we can integrate the RSA with our previous TCP socket. So as usual, I created a two function. The one, it's decrypt as well as the encrypt. The decrypt function is going to contain our own private key, and the encrypt function contains the Kali Linux or the attacker public key. So this public key belongs to the Kali Linux. Next, as soon as we get a command from the Kali Linux, we need to decrypt this command first, execute it, and once we have the result, we're gonna send this result to the attacker machine if it was less than 470 bytes. If it was more than that, we need to split that into blocks and send each block separately. On the Kali side, I did literally the mirror or exact thing. In the encrypt function, we load the target's public key, and on the decrypt function, we load our private key. And before we send any command, we pass that to the encrypt function. And once we get the result from the target machine, we pass that to the decrypt function. Okay, so let's start running the scripts. And as usual, I have Wireshark also started. So let me just minimize this. And we do have Wireshark here filtered on the IP address of the target. And also let me run from the target side. Okay, so we got our packets here. Okay, so let me start with basic command, something like cd commands, something small. The output is less than 470. We didn't get any problem. So also to verify that the traffic is encrypted, let's follow the TCP stream really quick. And this is exactly what people on the internet is gonna see once we send that, that shell to the target machine. So let's try another command, for example, who am I? Okay, but right now let's try with something interesting. Let's try with a command that it will get an execution output which is larger than 470 byte. And let's do, for example, ipconfig. Now, as you can see, the output is going to be sent in two parts. Here we got the first part. And right now, if we want to get the second part, we need to invoke another command. Let's say, for example, cd. And here is the second part of the ipconfig. And that will make a problem because we didn't get the entire output. And next time we invoke a new command like cd, the output is going to overlap with what is left from the previous command. So again, guys, the best way to use the asymmetric is the hybrid mode, and we will explain that in the next video. Okay, I hope that this lecture has been informative for you, and thanks for watching.